So for the last 3 days, we have found derivatives using the difference quotient, yes? And composite functions. Well, I've been going, well, but the derivative is this. And I haven't told you how I'm finding the derivative, have I?
Oh my gosh, this is an
So now I'm going to tell you how I'm going to find the derivative. We are going to be using the constant rule, the power rule, the constant multiplier rule, the sum and difference rule. Sounds like a lot of rules. And in 3 days, you're going to be like, I don't know that there's a difference in these rules. You're just going to find the derivative. So, are you ready for a password?
Yeah.
You have all ready. So when I walk back there, I can punch it in.
Yeah.
With how she introduced this chapter.
Okay.
Like a speech.
So now I have there, I think maybe it, yep. Okay, what I have here is the derivative of a constant function f is the derivative with respect to x, d dx of c is, guess what? 0. Didn't we find all day yesterday when we had a constant, what was the derivative after we used the
One less.
no, it was 0, wasn't it? When we had the derivative of 7, the answer was what? 0. So when we find the derivative of a constant, the answer is 0. Okay. So I didn't put this on widescreen. Sorry, guys. It's kind of cramped. Now, after you have that rule down, I want you to stop writing. Don't want anything else with this written on paper.
I wrote an example down.
You can write example, but I'm not there yet. Once everyone's done with the rule, I want you to look up at me.
I like how she's walking.
Well, I don't know why you're writing all those words.
I didn't. Wait, I'm just.
You should have the title, and you should have what?
D.
You should have the title, and you should have ddx. What does ddx mean?
Derivative.
Derivative.
Of x.
Derivative with respect to x. That is the only two things that you should have written down for that thing. Okay, so now I want everyone to watch. I don't want you writing this down at all because you did it over and over. Got me? Okay, so I have the derivative of c, some constant, is we have the slope of the tangent line, the derivative with the difference quotient that we used for the last 3 days, yes?
Yes.
So there's nothing to plug in there. So I have the limit of a constant minus the constant over the change of x
It's 0.
is 0 over the change of x, which is just what?
0.
0. Okay? The derivative, we graphed it yesterday and we saw that the slope was 0. Yes? Now, it is going to be wherever c is. If c is 7, it's going to be at what? 7. If c is -3, it's going to be at what?
Negative.
-3. Make sense? Okay, so the function, I have y, these are examples if you want to write them down. I have y equals 7. So dy of dx, that's another way to write the derivative of x, right? Derivative of y with respect to x. That's what that says, is 0. F of x equals 0.
0.
So the derivative, f prime of x is 0. S of t is -3, so derivative of s is what?
0.
0. Do I need to keep going?
No.
No. Any constant, what is the derivative?
0.
0. It's your first rule. Pretty easy, right? Okay, this is the next rule. Please do not write it all down. I'm going to talk about it, and then you can write. This is the power rule. If n is a rational number, then the function. So it just has to be a rational number. Got me?
Mhm.
So I have I have f of x is x to the n. Okay? The derivative with respect to x of x to n is n times x to the n minus 1. So what just happened here?
Just added an exponent.
The n goes where? Out in front, yes? And you subtract 1 from the exponent. That is the rule. So if it was me, I would probably just write that in power rule. This is how I was doing the derivative in my head so quick. Now again, d dx means the derivative with respect to x. dy dx means the derivative of y with respect to x. Prime means derivative. Do they all mean the same thing? Yes. We can just write them different ways. Again, everything in a red box is directly out of your book. And the reason I'm doing this is I want you to know that those are the things. Okay? And it just says at the bottom that it must be defined. Well, duh, right? Duh. You ready for the examples?
Yeah.
Okay. So, I want you to remember that there is a 1 in front of here, yes? Right here? There's a 1?
Where?
Right in front of that x? Isn't there always a 1?
Mm-hmm.
So if it's not a 1, you have to multiply the 2. So we're going to bring the 3 up front. So 3 times 1x to the 3 minus 1. Hopefully after this problem you don't have to do it so worked out, but I want to show it to you. Okay, what's 3 times 1?
3.
3. X what?
3x to the second power.
Okay. Did we not discuss yesterday how it's always 1 degree lower?
Mm-hmm.
Now do you see why?
Yeah. Can we do gx?
Hmm?
Can we do the gx one?
Yeah, we're going to do them. Okay, so the first thing I want to do, this is a power rule, yes? So I need to change this into a power, don't I?
Yeah.
So we're going to have to rewrite things. So this would be x to what power?
The negative third power.
Not the
The
negative,
1/3.
just the 1/3. Remember the power over the root, correct? So now I'm ready to go. So I have 1/3 times 1, which is 1/3, x to the 1/3 minus 1.
Would be negative 2/3.
It'd be negative 2/3. Well, now I have a problem.
Have a negative in it.
I have a negative in the numerator. Well, I have a negative and a fractional exponent. That is a big problem. I can't have either one of those. I can't have a negative exponent, and I cannot have a fractional exponent, can I? No. So I've got to work on that. So let's see. Negative exponent takes it to the where? Denominator, right? Okay, I'm going to erase my work over here so I have room to write. Because I didn't widen the screen, so it's shut it all down. So I'm going to have, this is going to come up here. So I'm going to have 1 over 3, because 3 is already in the denominator, correct? X to the 2/3. Well, what do I need to add to 2/3 to get to 1?
What happened to the negative?
And when I move it to the denominator, what the negative is gone, remember? Okay, so what would I need to add to 2/3 to get to the next whole number?
1/3.
1/3. So if I do x to the 1/3 in the denominator, I have to do x to the 1/3 in the
Top.
numerator. So down on the denominator, I have 1/3 plus 2/3, which is what?
1.
1. So I have 3x, correct?
Or 1. Or no.
No. Okay, so what's 1/3 translate back into? What root?
Square root.
Not square root.
Sorry, third root.
The cube root of x.
Dude, my foot fell asleep.
Okay.
Well, you were sitting weird.
How are we supposed to do that in our head?
You're not supposed to do that in your head. You were not. I could see you getting to this point in your head,
Yeah.
but not this you'd have to work out. Okay. So now here, I probably don't want to deal with it in the denominator. I need to bring it to the numerator. So how would I rewrite that? X to the what? If I'm taking it out of the denominator and bringing it to the numerator, what happens to the exponent?
It reduces.
Nope.
Multiplies. Doubles.
Shelby?
Negative.
It becomes negative. Over here, I took it out of the numerator, and put it in the denominator, so it came positive. If I take it out of the denominator and bring it to the numerator, it's going to switch signs, isn't it? Okay. So I have negative 2 times x to the negative 2 minus 1. So what do I got?
Negative 3.
2x to the
Negative 2x to the
negative third.
negative third, but I can't leave the negative there. So it's in the numerator. I have to put it in the denominator, but only the x, correct? The 2 does not,
Two.
negative 2 over x cubed. And once I do that, now, do you see why last year I was pushing so much with exponents and things like that? This is your entire year from here on out as exponents and fractions. This is basically it. We just add more rules to it. So we're going to get better and better and better at them, correct? Okay, so this is the power rule.
Wait, that's our answer, negative 2.
Yes.
X third.
Yes. Okay, so now it says find the slope of the graph f of x equals x to the fourth at negative 1, 0, negative 1, 0, and 1. Yes? So I'm going to find my slope function, and then I'm just going to plug in 3 different numbers, aren't I?
Yep.
So the slope function is also known the derivative, correct?
Mm-hmm.
So f prime of x equals, what is the derivative of x to the fourth on your own? The rule we just got done using, right?
4x to the third.
4x to the third. How'd you get that, Riley?
I just took 4 times x and I took 4 minus 1 from the exponent.
Okay. Everyone follow?
Yes.
So I now have, this is the slope of the tangent line, correct? The instantaneous rate of change. So f prime at negative 1 is 4 to the times negative 1 to the third, which is what?
Like,
Just negative 1.
Negative 1 times 4, which is
negative 4.
negative 4.
Oh. Yeah, ignore that.
So f prime
Oh shoot.
At-
I got that wrong.
0, what'd you
I
do?
was being stupid.
I was gonna multiply.
I was trying to cube it.
Yeah, me too.
You got to cube 1, not 4.
Yeah.
Okay, so 4 times 0 cubed, which is just what?
Still 0.
4. Or 0. not 4.
We're getting there.
Yeah, we're here. If we can remember third grade math. Okay, then the derivative at 1, which is the slope at 1. Yes, it's the slope of the tangent line at 1. Is 4 times 1 cubed,
Which is 4.
which is 4. So all of these are the slope of the tangent line, right? Oops, at x. Because the whole point of a derivative is find that instantaneous rate of change. Because is the slope constant of x to the fourth?
No.
No. Now you wish you had this rule. Yes?
But I feel like not all of them were as easy as that.
Yeah.
They don't get much harder for a while.
See, it's like,
For a while, so like
in
2
an
problems.
equation. Let's say, like, in,
Today's are pretty much this.
Okay.
are there any equations?
Just
Like,
okay, find the equation of the tangent line. Guys, what is the equation of a tangent line?
The slope of the tangent line.
No,
Or the derivative.
the derivative. Okay? So when you see the equation of the tangent line, what is it telling you to find?
Find the derivative.
Find the derivative. If you don't know that or don't see that when you read it, you need to write it down.
yes, ma'am.
Correct?
Yes.
Okay, so find the equation of the tangent line. And then we'd find the slope when x is negative 2. Yes? So, you guys find the derivative of that?
Yes, we can do it all on our own.
I hope so. Maddie, what do you get?
Wait.
I know, just when you get it. When you get it.
Can you write that?
how you did it.
My slope is 8.
This is supposed to be easy.
That is confusing.
Oh, I got 2x.
That's what I wanted.
So
Yeah, but my slope is 8.
where are you plugging stuff in at to get the first?
Your slope is
I'm not
eight.
plugging anything in to get the derivative. I'm taking the 2 out front and subtracting 1 from the...
'Cause you put in-
Negative.
Now, my slope of my tangent line
Sorry, guys. We can't all be as good as Riley.
No, I was just. I
is
was
2
wondering
times
if
negative
it's
2.
Isn't it negative 4?
And yes, it is negative 4. You
Yeah.
forgot your negative.
No, I
So the
squared the negative 2.
Oh.
the derivative is 2x.
Yes, the derivative or the equation of the tangent line is 2x.
And then
The slope of the tangent line is what?
negative 4.
Negative 4.
Or like Maddie said, 8.
Gentry, did I answer your question?
Kind
Okay.
of. Oh, shucks.
Am I good?
Yes.
Yes, ma'am.
Gentry?
Mm-hmm.
Okay, so now here is the constant multiplier. I always forget to turn on my pen. Constant multiplier rule. Now be careful what you write down, so let me talk and then I'll give you time to write. If f is differentiable function and c is a real number, so you can find the derivative and c is a real number, this is what you do. And I already talked about it, but now they put it into a rule. Right here. So if I have the derivative with respect of x of c times f of x, you just take c times the derivative. What that means, guys, if I have f of x equals 6x cubed, I take 6 times 3x to the 3 minus 1. Weren't we? Didn't I already discuss this?
Yeah.
So 6 times 3 is what?
18.
18 x squared is the derivative.
The red box, that equation doesn't make sense to me until you do that.
Right. That's so you can write this equation down and then put your example. This is just a proof. Don't write it down. We'll go over it. And actually, I'm not even going to go over the proof.
Okay, can you not?
Okay,
This side.
okay.
Oh,
Yeah, she's really good. Yeah, I think we understand it.
Well, you guys are writing, so am I.
Okay.
Is
Oh.
Can you draw a picture of me?
I was going to draw a dog. Not you.
That's a terrible dog.
That's not very nice.
I'm not there yet.
I'm scared.
I was actually gonna give you credit for like being good at math and like being creative, but like
Thanks, Gentry.
Whoa! Look, the ears are different colors.
that was a scary dog. That looks like a sheep.
Yeah, it does look like sheep. Okay, it's a sheep. See, I'm just going to draw a body behind him.
Aw.
See, it's a sheep.
That looks so much more like a sheep than a dog.
There you go. It's a sheep.
It reminds me of
Oh, he needs some eyebrows, doesn't he? He had a big forehead.
Hey,
Give him a little poof on his head.
Yeah, give him a little poof. Oh, no.
Look,
Okay.
see? Oh, he doesn't have a nose. He needs, like, a nose.
Oh, you ruined it.
I did.
They don't have human noses. They have.
Oh, well, you guys got your rule written down yet?
Someone's looking up how to find the constant multiple rule and finds this.
You should have this be the thumbnail with the sheep.
So every time I'm waiting for you guys to draw it, I'm just going to draw this human-looking sheep.
No, you have to draw a new farm animal every time.
Yeah.
Every time.
Animal every
Do
time.
a horse next.
That
I'd
sheep
love to see
turned
that.
really scary after you.
Nose, yeah, really.
Just take a
But it
little
needed
smile
something.
And connected it and made that like a sheep.
That looks like
Oh.
a human.
Okay, anyway, are we done?
Yes.
That's terrifying.
I turned a human into a sheep. Okay. So,
The dog is
now, we're going to rewrite this, yes?
Yes.
It's,
Can we have a second to write this down?
well, just y equals 2 over x.
Girl.
Just one. Write one at a time.
This is for the constant multiple.
Yep. Basically, the constant multiplier and the first one are the same thing, just because the coefficient was 1, right?
Right.
Okay, so I need to rewrite this. I need to bring the x out of the denominator. So what do I need to do with its power?
negative.
Negative. So it's 2x to the what?
Negative first.
Negative first. So do your problem.
Did I have the password to E3?
Did you pass?
Yeah.
Awesome. Riley, what'd you get?
Negative 2x.
Close.
Okay.
To the negative second.
So the negative second. Because negative 1 minus 1 is negative 2. Yes?
Yes.
Can I leave it like that? No. So I have negative 2x to the negative second.
Square root.
Nope, not square root.
You put it on the bottom.
I put it x back on the bottom, right?
Read negative 2 over x squared.
Negative 2 over x squared.
Boom!
Okay?
I thought you
We
said
moved it.
I thought you did too.
I know. She said more sense. You made it negative to bring it up, so we just bring it where? Back down?
Right.
Okay. So, what is my constant on B?
Dude,
5.
Uh-uh.
4.
4.
Uh-uh.
1.
T.
4/5. Yes? So I could rewrite this as 4/5 and t squared, couldn't I?
Yeah.
Make it look better?
Yeah.
So now do it.
Got it.
Got it?
Boom. You're so smart.
Sadie, you got an answer?
No. Not even close.
Shelby, you got an
My
answer?
brain doesn't
Give
work.
me a minute.
You guys are thinking too hard.
I had it last time.
Riley, can you help me out?
Wait.
Guys, what's 2 times 4?
8.
8, that's it.
8/5.
8/5.
Yeah, I know. I
Oh.
was just finishing it.
I'm trying to figure out why it's taking so
Can
long.
you get rid of the T?
No, you still got 1, don't you?
8/5 T.
Yep.
That's confusing.
Why?
No.
What's 2 minus 1?
I don't look at 4t squared over 5 and
Right, so that's why I did what?
think like that.
Why did I do this?
So you could just do t minus 1. And
Right.
Tells you.
When I rewrote it, you take 2 times 4 and get 8 and minus 1. Don't make these harder than they are, okay? What I'm doing with the rewriting is making them easier for my brain to manipulate them. Okay, so what about the next one? I have 2 square root of x.
You gotta get the x out of it.
2, what? What'd you say? Oh, so I have 2 times x to the 1/2, right?
Yes.
So I take 2 times what?
1/2.
1/2. And then I'm going to have x to the what now?
Negative 1/2.
Negative 1/2. Well, 2 times 1/2 is
1.
1.
1x minus 1, but it would be 1 over x to the first. 1 over x.
Okay, so it'd be 1 over x to the 1/2.
Yeah.
But I can't leave the half. So what do I need to add to a half to get to the next whole number?
Oh, you have to add
Another
x
half.
to the 1/2.
X to the 1/2. I'm just rationalizing it like we've done before, but just with exponents. So 1/2 plus 1/2 is
1.
1. So it's x. Yes, Maddie. And x to the 1/2 is the,
Numerator.
yes, but isn't that the square root of x?
Yeah.
So right now, this isn't coming second nature. Is it going to get there? Especially with
Hopefully.
things like 1/2 and 1/3. Yes. We're going to keep working with these. So if you're struggling, after tomorrow, we need to really work on them, right? Because that's what tonight is to get over some of these things. Okay.
This one looks scary.
It looks scary, but we're not going to make it. It's not going to be too bad. Okay, so what's my constant on this 1 over 2, the cube root of x squared?
1/2.
1/2. Okay, so we're going to bring out the 1/2, right? And then what's my exponent here? Two thirds.
Yes.
But it's in the denominator. I want to bring it to the numerator.
So you just flip flop them, right? No, negative.
Negative.
2/3.
So I have x to the negative 2/3. So I just rewrote this problem so I can use my power rule, didn't I?
Mm-hmm.
Okay, so I'm going to take 1/2 times what?
Negative 2/3.
Negative 2/3. And then I'm going to have negative 2/3 minus 1, which is 3/3, correct?
Minus 5/3.
Minus 5/3. Remember, I didn't write minus 1 because that would have done me no good, would it? I just got common denominators right away. So now the 2 and 2 reduce, so I have negative 1/3.
Yeah.
And this negative 5/3, that has to go to the denominator, doesn't it?
Mm-hmm.
Oh, what did cancel that? I don't know what that just happened. Okay, so I have x to the 5/3 down here. How did it go back to the denominator? Because it was what up there?
Negative.
It was negative, so it has to go back to the denominator, doesn't it?
Mm-hmm.
Okay,
Why does the 3 go with it?
because it's 1/3. 3's already in the denominator.
Yeah.
Okay, so what do I have to add to 5/3 to get to the next whole number?
1/3.
1/3. So here and here.
We're
Yes?
going a little fast now.
How did Shelby get x to the 1/3?
Because 5
Is 1 away
plus
from...
1.
Right. 5 is 1
Make
away.
it 2.
Right? So if it was 4/3, I'd have to have 2/3, wouldn't I? Okay. So now the numerator is going to be what root? What root? Cubed root. So I have negative the cube root of x, yes?
Yep.
Over 3x to what power?
Second,
Second. How'd you get second, Riley?
because 5 plus 1 is 6, and 6 over 3 is 2.
Right. So
Boom.
I hope you worked that down and not across.
Ah.
Okay.
I kind of went like this.
Now, the reason why I say that is my screen goes across and I need to fix that. Because when I look at this problem on my screen, can you quickly distinguish step between step between step?
I mean, not really.
No.
It took me a hot minute.
Yes. So when we do these problems, which way should we be working? Down. Okay? Because of the fact if I work down, I'm going to see step, step, step. Is it going to be easier to see what's going on?
Yes.
Yes, I need to quit cramming things in on slides. I apologize. Okay, do you want to try E on your own?
Negative 3 over 2x.
Yes, that would be how you would rewrite it. So Maddie says negative 3 over 2x. How'd you figure that out, Maddie?
Negative 3 over 2 is my constant.
Right.
I got
Oh, I didn't see the negative.
I got
on the
negative 3
original.
over 2x as my answer, though.
Nope.
I'm so confused even how to use circle.
Okay, well, what's my exponent?
1.
1.
It's 0.
No, it's not 0.
Well, I know it's 1, but I get 0.
You get x to the 0, which is what? 1.
Mm-hmm.
So it's negative 3 halves.
So it's negative 3x.
Excuse me, is Donald your day, yes, sir?
Yes, he is.
He needs to come to the office. He'll be leaving.
Okay. Have
Why
fun.
don't you have a clock in your room?
Okay. Okay, so this was the rule we just got done doing, didn't it? I'm going to move this, and it's going to go away. Ignore me.
Okay.
Okay, so there's some things we're just different. We got fine derivative examples. I've just got more examples here. We can keep going over them. We can combine the two rules. Got it?
Do we have
So-
to write that down, or can we just?
Well, I have a question. Do we need to work these out?
Yeah.
Okay.
It would help.
Or is there one specifically, like A?
I think we should work them out, but I'm
Okay.
not writing them down.
That's fine. I'm going to actually work them on the side and erase them as I go. You got it?
Yeah.
Okay, because I want to work down. Make sense?
Yes.
Okay, so how am I going to rewrite the first one?
5 halves x to the 3rd.
5 halves x to the
3rd. 1/3.
Oh, negative.
negative third. Why negative third?
It's in the
It's in the
bottom.
bottom.
It's in the denominator. I need to bring it up. So I have 5 over 2 times negative 3x to the
-4.
negative 4. So nothing reduces over here, does it? So then I have negative 15 over 2. And x to the negative 4, so the x goes where?
The bottom.
Back to the bottom.
Got it.
Okay? Now, this has 2x quantity cubed. So what do I need to do first before I even
2x
start?
times 2x times 2x.
So 2 times 2 times 2 is
6.
8.
8.
Okay,
Shoot.
now that I do this, is this problem any different than that?
No.
No. So do I need to do it? No. Okay, that's what I want to show you. Do I sometimes have to do some manipulation before I can even do that? Okay,
Why did we keep the 3?
because it's x cubed. You have to cube both.
Oh.
Okay, so now here, is there any manipulation I need to do to this one though?
Yeah.
I have to move the 2 where? To the top. So I have 7/3 x squared. Well, that made it positive. That's nice, right?
Right.
So multiply times 2, and I get 14/3. What?
X.
X. It looks bad, but is it that bad to do? No. That's what I'm trying to get at. Okay, now this one. What is the negative? If the negative's on the whole denominator, yes?
Mm-hmm.
So that means it all goes where? To the top. So what's 3 times 7?
20. Yeah.
So I have 21 x to the second. So that gives me 42x. Correct?
Oh, wow.
Okay. So the whole point of this thing was these look horrible, but were any of them really that bad? No. So when we see one, we need to write it down and say, what can I do to make this easier to work with? Got it?
Got it.
Okay, now take a breath. Disregard the crap up there. I have the sum and difference rules. Okay, now look, just really look at what this says. If I have the derivative of one function plus the derivative plus another, I just take the derivative of the first and add it to the derivative of the second. What do you think if it's minus?
The same
The
thing.
same thing. So you know what I would do? I would write your rule, and when I wrote this on my paper, I would write plus, minus, and plus, minus. And guess what? You only have how many equations? One. Basically says when you have the sum or difference, just take the derivative of each one separately and combine them. Yes? So when you saw that, you started panicking. I know you did.
I didn't.
Good. I've taught you something. Control your emotions.
No.
So, when you see them, then you're not supposed to see one problem. You're supposed to see individual terms as problems, correct?
Correct.
So when you go back through your notes or you're working tonight, I would definitely highlight all of your rules. Would that make sense to do?
Yes.
Another thing I would probably start is a piece of paper that says derivative rules. And every time we get a new rule, that night you go home and put it on that piece of paper. Does that make sense? Because then you will have a sheet of all your what?
So we did 4 rules
Derivative.
today.
Yes, we did. Well, basically the constant multiplier is 1. Basically we've done 2. Okay, so,
Wait, can we do the example?
yep, let's do the example. So, how many problems do I have in f of x? Do I have one problem? I have what?
3.
3. Actually, we did 3 rules because we did the constant one. Okay, so we're going to take the derivative of each one individually. Got it?
Got it.
So the derivative of f of x. So what's the derivative of x to the third?
3x to the second.
3x to the second. Didn't even need to write anything down, did you?
Nope.
Already. Okay. What's the derivative of negative 4x?
Just 3x?
Negative 4.
It's just negative 4. Because what's the power? 1.
Yeah.
1 times negative 4, and then you'd have x to the 0, yes?
1, which makes it 1.
Uh-huh. And what is the derivative of any constant?
0.
0. So I'll write it down, but my final answer is just what?
3x squared minus 4.
3x squared minus 4.
Squared.
What?
Squared.
Oh, I forgot my squared on my x, didn't I?
I just meant 4 squared. Was it funny?
I'm like, no, it's not.
Okay. The next
Okay,
one,
now the next one, all we see is 1/2 there, don't you?
Yep.
Yep. Do I need to freak about it? Nope. Okay, so I basically have y prime, which still means derivative, yes?
Yes.
So I have negative 1/2 times 4 x to the what?
Third power.
Third, plus
Was
9x to the second.
9x to the second
Minus 2.
minus 2. And I wrote this out over here because I may take a minute to do that one, right? Half of 4 is what?
2.
2. So negative 2x cubed plus 9x squared minus 2. Did I go down 1 degree from the beginning?
Yep.
Yep. Not too bad, huh?
Mm-mm. Is that all the notes for today?
Let me see what the next slide is.
We have 2 minutes.
Okay. If we had 2 minutes, my alarm should be going off.
3 minutes.
Am I good to see if the next
Yeah.
slide? Okay. Go ahead and write these. These are just special rules. These are just special rules, guys. Like we had the limit special rules, right? So these make the next ones, right? So the derivative of the sine of x is what?
Cosine of x.
Yeah. That's it. Okay? And the derivative of cosine of x is what?
Sine of x.
Nope.
Negative sine.
Negative sine of x.
Well, that's not confusing.
Now we have 2 minutes. And we'll do these 3 examples and we'll be done.
Oh gosh, I'll never get those written down.
Well, maybe we just do them and you go back and watch the video to write them
Oh, I
down.
won't ever do that. That is true.
Okay, you guys got the rules written down?
Yeah, we can go.
Okay. So, now 2 is a constant, yet like it's a multiplier? Yes?
Yeah.
Okay? So it's going to be 2 times, and what's the derivative of sine of x?
Cosine.
So it's cosine of x. That's it.
Oh, that's
That's
like,
it.
That's like it.
It. Okay? So do I have a constant on this one? It's 1/2, isn't it?
Yes.
Okay? So it's 1/2 times the derivative of sine of x, which is what?
Negative sine. Oh,
No.
sorry.
Oh.
Cosine of x.
Cosine of x.
I didn't know they were this short.
Yeah. Okay, now here I don't have one problem, I have what?
2.
2. So what's the derivative of x?
X.
No.
0.
0. No.
It's 1.
It's 1. Correct? Because you have a bunch of ones.
Yes.
And what's the derivative of cosine of x?
Negative sine x.
So negative sine x.
I swear, if the ones on the assignment are harder than this, I'm coming
The
out.
only way I could make them harder